Hi there, and welcome to this lesson on A-Level Pure Mathematics 1. We're on Chapter 1, and we are up to 1.4, Negative and Fractional Indices. We'll begin by looking at negative indices. People sometimes get confused as to, well, I think why really negative indices work in the way they do. One of the best ways to understand where they come from is to consider normal powers. So if you had 2 to the power of 4, that's 2 times 2 times 2 times 2, which is 16. Divide that by 2, and you have 2 cubed, which is 8. Divide that by 2, you have 2 squared, which is 4. Divide that by 2, you have 2 to the power of 1, which is 2. Then we hit one of the first interesting ones. Divide by 2 again, the power goes down by 1 again, and it goes down to 0. 2 to the power of 0 equals 1. In a similar fashion, you can show that any number to the power of 0 must equal 1. Keep going down, take another 1 off, and you'll have 2 to the power of minus 1, which means we've divided by 2 again. 1 divided by 2 is 1 over a half, or 1 over 2 to the power of 1. Divide by 2 again, we'll have a quarter, or 1 over 2 squared. Divide by 2 again, we'll have 1 over 2 cubed. And so you can see the pattern. 2 to the power of minus 1 is 1 over 2 to the 1. 2 to the power of minus 2, 1 over 2 to the 2. And so on, and so on. Okay, have a go at doing these 6 examples. Don't look for anything complicated here. We are just rewriting them. So when it says minus 1, you're going to do 1 over. In fact, when it says minus, you will be doing 1 over something. Pause the video, have a go at doing these 6 questions, and then come back to me. Okay, as I was saying before, nothing too strange going on here. X to the minus 1 just means 1 over x. 5x to the power of minus 3, just one thing to be careful of. The minus 3 goes with the x. It does not go with the 5. So the 5 stays on the top. It's only x cubed that goes down to the bottom. If it's a bracket, you treat it in the same way. X minus 5 to the power of minus 2 will be 1 over x minus 5 squared. 4 times x minus 5 to the minus 2, again be careful, the minus 2 is only operating on the bracket, it's not operating on the 4. So that should be 4 on the top there, I apologize, that's a mistake. It should be 4 divided by x minus 5 squared. Question 5, you've got 2 brackets. The second bracket has minus 4 applied to it. The first bracket has nothing applied to it. So the first bracket will just stay on top. It's the second bracket that goes down to the bottom because of the minus and becomes 3x minus 2 to the power of 4. This last example, you have a confusing thing in the bracket now. You've got a trig function. Again, the minus 1 just applies to the brackets. It doesn't apply to the 4. So you'll have 4 for the numerator, and the denominator will be 6 sine theta minus 2, all to the power of 1. If it's just to the power of 1, you don't need to write the 1, you don't need to write the brackets. Okay, fractional indices. You may well have met in the past that x to the power of a half means the square root of x. Well, why does it? Why does root x equal x to the half? This is really just showing that it works in exactly the same way. By definition, root x times by root x would give you x. Root 4 times root 4 would give you 4. Works the same if you have x to the power of a half. So x to the power of a half times by x to the power of half. Using the normal rule with indices, that's x to the power of a half plus a half. Half plus a half is 1. X to the power of 1 is x. So root x times root x is x. X to the power of a half times x to the power of a half is x. They're the same thing. In a similar fashion, you can show that the cube root of x is x to the third. The fourth root of x is x to the power of a quarter. Something more complicated, where you have, say, the cube root of x squared, that would be x to the power of 2 over 3, where the power of 2 goes on the top of the fraction, and the root goes on the bottom of the fraction. So in general, a to the power of 1 over m means the mth root of a. A to the power of a half is the square root of a. A to the power of n over m is what we were just talking about. That would be the mth root of a to the power of n. So the number on the bottom becomes the root. The one on the top becomes the normal power. The thing we started with, a to the power of minus m, the minus just means you've got to do the reciprocal, 1 divided by. So 1 divided by a to the power of m. Anything to the power of 0 is 1, which always feels surprising, but is true. The rules for powers, they still work with fractional and negative powers in exactly the same way. So a to the power of m times a to the power of n, you add the powers. A to the power of m divided by a to the power of n could be written like that, which is how you would normally see it written. You subtract the powers. A to the power of m, all to the power of n, then you multiply the powers. Okay, that brings us to the second set of examples. Have a go at doing these yourself. Simplify each of them. You're not finding any answers, you are just tidying things up. That's what simplify means, really. Write the answer in the neatest way you can. Pause the video, come back to me once you've had a go. Okay, we'll go through these together. The first question, x cubed divided by x to the power of minus 3. Well, you're dividing one power by another, so you'll be subtracting 3, take away minus 3. Be careful with the 2 minuses there. That gives you x to the power of 6. Second question, 2x to the half times by 3x to the 3 over 2. The 2 and the 3 you just multiply in the normal way. 2 3s are 6. The powers you add in the normal way. A half plus 3 over 2. That gives you 6x squared when you add the fractions together. The third question, 4x cubed, all to the power of 3 over 2. Now, I think I would probably split this up into 2 parts just to make it feel a little bit simpler. And you can do this as long as it's a multiply or a divide in the brackets. So you've got 4 to the power of 3 over 2 times by x cubed to the power of 3 over 2. And then think about the 2 things separately. That means we've got 4 cubed, and then we'll have to square root the answer. So you do 4 cubed first, which is 64, and then the square root of 64, which is 8. And we haven't done anything yet with that, but we'll have a look at that now. X cubed to the power of 3 over 2, cubing it first, that means you'll have 3 times 3 is 9. And then square root, the 2 means we'll have to divide the 9 by 2. So we've done 3 times 3 over 2, which is 9 over 2. And that's as simple as it gets. The fourth question, 6y to the power of 2.5 divided by 2y to the power of minus 0.5. First thing I'd say is this, I would not write decimals. In this sort of context, decimals are rarely the best way to write things down. Occasionally they might be, but a fraction is nearly always the best way to write it down. Having said that, it still works in the same way. Writing the division as a fraction, which is how you would normally see it in algebra. Then you've got 6 divided by 2, that's 3. And with the powers, we'll be doing a subtraction. 2.5, take away the minus a half. So 6 divided by 2 is 3. 2.5, take away minus a half is 2.5 plus a half, which gives us 3y cubed. The fifth question is the cube root of 27a to the power of 12. Well, the cube root of 27 is 3. The cube root of a to the power of 12, you do 12 divided by 3, which gives us 3a to the power of 4. The sixth question, you've got 2 things being divided by w to the power of 4. You do them completely independently. So looking at this first one, you've got 3 divided by 1 is just 3. 3 take away 4 gives you the minus 1 there. And then we've got minus w divided by w to the 4. There's no power written with the w. It's w to the power of 1. 1s don't get written down. 1 take away 4 gives you the power of minus 3. And that's just tidying it up a little bit more. So the negative means you've got a reciprocal in both cases. So you've got 3 over w minus 1 over w cubed. And again, that 1 comes from the 1 in front of the w that is not written down. It's just assumed to be there. 25 to the power of 3 over 2. You can choose whether you do the cube first or whether you do the square root first. Now, if you've got a calculator, it makes no difference. But if you haven't got a calculator, the square root is easier to do first. The square root of 25 is 5, and then 5 cubed will give you 125. Question 8, a to the power of minus 2 over 3. There's a lot going on there. I would deal with the minus, I think, first of all. The minus means you've got 1 over. So that's 1 over 8 to the power of 2 over 3. The 3 means the cube root of 8. Well, the cube root of 8 is 2, because 2 times 2 times 2 is 8. And then you've got to square it. 2 squared is 4. So 1 over 2 squared, 1 over 4 will be the answer. If you've got a calculator, you can throw all of this into the calculator in one go, and the answer will come out. But it is good if you understand exactly what's going on. Question 9 is a little bit different. It says, given that y equals 1 over 16x squared, express 4y to the power of minus 1 in the form kx to the n. So 4y to the power of minus 1. That's what they've asked us to look at. First thing I would do is say, well, the minus 1 means I've actually got 4 divided by y. I know what y is. Y is that. So I can substitute that in for y. So I've got 4 divided by this expression here, 1 over 16 x squared. Now, 4 divided by 1 over 16 is the same as 4 times by 16. If you divide by a fraction, it's the same as multiplying by the same fraction, but upside down. So 4 16s is 64. We'll have 64 over x squared. Just looking at the question is said express it in the form k times by x to the n, which is why it's been rewritten again here. 64 times by x to the power of minus 2 isn't necessarily the simplest way to write it down, but it is the form that the question asked for. That's all the answers written down, and that gets us to the end of the lesson. If you have the textbook, then page 11, exercise 1D is the exercise you should be looking at. Okay, thank you very much for watching, and cheerio.